All right, good afternoon from my end. Okay, so today is another day. I think this should be the week 3, the first day in the third week, right? So after this week, we'll be having just one more week to round up this Python introductory classes. So for today, from the outline I designed, we're having data structures part 1. So data structures, you cannot do data science or data analysis or analytics without data structures, right? So that's why I decided that these data structures should be broken down into 2, where I will have data structure part 1 to cover list and tuples, and then data structure part 2, there will be handling other components of data structures, right? So we're going to look at, as far as we can, we're going to look at all what is required for us to understand lists and tuples. So I have 2 topics here. The first is list and list operations, right? Then I also have definition and characteristics of tuples. And in brackets, we have immutable sequences. Immutable in the sense that you cannot change things in once they are tuples. So, but for your list, they are usually mutable. So you can play around with them, you can change and mutate them without having any form of error. So let's start with list and list operations. For lists are the most versatile and commonly used data structure in Python, right? So there is no data structure that you will see that will not have at least some of its parts to contain a list, right? So most times I used to see list as a container that allows or that accommodates items of different categories. So it could be that you could have an integer inside of a list. You could have any form of character, parameter, or variables appended in a list. So let's continue. A list is an ordered, take note of the words, mutable collection of items enclosed in a square bracket. These are the unique characteristics of a list. The first thing is that a list is usually ordered. So it could be is either they are being ordered or shuffled in a specific way or as the user defined them. Also, there are mutable collection of items. When we talk about mutable collection of items, we refer to the fact that we can make changes to the items in that our list. So it's not like the tuple that's when you impute an item inside the tuple, it becomes very difficult for you to make changes to that item. So, but for a list, you can have those items and as well make changes and corrections in cases where you have or when you encounter mistakes or errors. You can always try to tweak and see how you can make changes to them. And then there are usually enclosed in a square bracket. A square bracket. This is a square bracket inside this brace, this one. So once you see that square bracket, you should know that this is a list, right? So you should always know that this is a list. Let's move forward. The items in a list can be of different data types. I said that already. But for clarification, when we mean different data types, we are looking at integers, strings, floats, or even other lists, right? So it means we can have a list inside another list, right? So that makes it interesting. So aside the fact that we can have integers, we can have strings, we can have floats, we can as well have lists inside another list. So this is an example of a list. Here is it. When I say this is an example of a list, once you see an item like this that has a square bracket, right? You should know that this is a list. So we have empty, okay? All right. Empty underscore list. Let's try to see what will come out. It will be an empty list like this. Why is it an empty list? There is no item in this list now. So look at list as your shopping cart. Your shopping cart, right? So you can impute any item, any grocery, whatsoever you purchase into that cart, right? And it's possible that you may want to replace a particular item for another. So that is why we can always liken a list to that a shopping cart. So, but at this point, we've not started imputing items on this. So this will come out empty because there is no item inside of it. So, but we can have, there are times where we have okay, sorry, my bad. So I said that, right, I think we're good now. So there are times where we can have a list of integers. So here is it. We have a list of integers and looking at this list, so this is looking at this list, we have integers all around. We have 1, 2, 3 to 5 here, right? And then when we want to print this guy, you have it to be what? Like this. This is because you now have items inside of this list. So mind you, the right of numbers is numbers is a variable name for this list. So if you look very closely, we have 1, 2, 3, 4 down to 5. And then when you print this, it's going to give you those integers rather. And then you can have a mixture of strings, floating numbers, and then integers, right? And this is a nested list where you have a list inside of another list. So all of those are typical examples of list, as the case will be. All right. So let's try to see how this our nested let's see how our nested list will appear. So we run this. Here's it now. We have a list nested inside another list here, right? So that's that. So we want to be looking at accessing key elements. In Python, it is known as slicing. It is known as indexing and slicing. So for indexing, let's say we have numbers, right? Look at these numbers here. These numbers is a list of integers. Let's bring it down here. So it's a list of integers. Then we have 1, 2, 3 down to 5. So if I want to pick out the first value here, the index number for the first value in our list is usually 0. So what do I mean now? For these numbers, the integers will be, the index values will be 0, 1, 2, 3, and 4. So while this 0 is representing the first value here, this one is representing the second value, and this 2 is representing the third value. This 3 is the index number for this fourth value, and the 4 is the index number for the fifth value. All right, let's quickly see if that is true. So we want to pick out the first value, which is 1, right? So we use our print function, print numbers, then your index value. Remember, for you to use your index value, you need to put a square bracket beside the variable name of your list. And in this case, the variable name of our list we are working with is numbers. And then the value we want to pick out is the first value. That's why we're working with the index number 0. So if you run this guy, it's going to give you 1, right? So the index number increases from left to right, starting from 0. And then in the other way around, it decreases from right to left, the negative axis. So we can say that we want to pick the last value and we are going from right to left. So let's, oh, okay. We can, okay, let's see what we can do. All right, we can have -1 here. When you have -1 here and we run this guy, what is showing here is what? 5. So, but because we are saying that it increases from left to right and then decreases from right to left, it means that if our -1 will output for us the last value, that means -3 will give us this third to the last value. So printing this will have 3 as the output. So mind you, we can as well use our normal configuration of increasing from left to right. So I can have 4 to output for me. 4 will output for me 5, right? That is based on our normal convention of increasing from left to right. That is it. All right, another thing is we can as well do this for the same for other lists as well. So here is an example I made with mixed list, which is this guy that has Apple, it has 3.14 and it has 42 as its values. So if I should run this guy, remember, we have here, this is the first value, right? This is the second value, and this is the third value. But if we're working with index number, this has an index number 0, index number 1, and index number 2 for this one. So that is why if I have mix underscore list, open bracket 2, close the square bracket, it should be outputting for me 42. So if I should have here to be, if I should have here to be, let's say 0, and I run this guy, I'll be having Apple to be my output. Reason is that this Apple is the first value on our list. So it will go with is the first value on this our list. So it has to go with what? The index number 0. All right. Then another thing, we can as well perform slicing on those integers. Let's bring them down. Let's bring the list down. So slicing means extracting of a sublist using the colon operator. So if I want to say, I don't want to pick just one value, I want to pick more than one value, and I don't want to just pick them anyhow. I want to pick them in a systematic way, either from left to right or right to left, as the case may be, right? So this is it now. We are trying to pick the values. This is how slicing works. Let me bring this guy out so I explain better. All right. Um, Okay, so I have numbers. Mind you, numbers is the list of our integers from 1 to 5. And this is numbers. And then this is how the slicing looks like when you want to slice. Let's say, for instance, we want to pick out the second value and the third value. This is what you do. All right, look at it now. The first number here represents the stats index number. I go over it again. The first value in this your slicing represents the first index number, your stats index number. That is the number that has the value that has this stats index number is what is going to display first. And then the column indicates that we are not just dealing with one value. We want to get a range of values, but in a systematic way, right? And then it will now request that you should indicate the end point. We started with index number 1, and we're ending with index number 4. This is a trick now. The index number 4 will not display the value in this fourth index value. Let me go over it again. Here, let's bring this guy. Let's bring this guy up. Oh, sorry. All right, so we have 4. We have numbers, opens bracket 4. So this is going to display for us 5, following our normal convention of left to right. There'll be an increment, right? And then if you look at 1 will be, we output for us 2. So having known that our first value should be 2, it means that the fourth index number here, which is 4, represents the fifth value on our list. I don't know if you understand that. So it represents the fifth value on our list. Why am I emphasizing on this? I'm emphasizing on it because when you have done the slicing, the fifth value will not be at period. The result will not contain the fifth value. So that is where I am driving towards now. So if I should run this code now, I'll be having 2, 3, 4. So it means that it will display for me 2, which has an index number 1, index number 2, and index number 3. So it's excluding the index number 4. So that is to tell you that whenever you want to slice, your first value here represents the index number you're starting with. It represents the value of the index number you're starting with. So assuming we started here with 0, so it means we would have included 1, right? So this will be 1 down to 4. So because we did not do that, we started with 1, it will begin from 2 because 2 has the index number 1. And then another beautiful thing is that it doesn't include the value you're ending it with. So it stops at the last value minus 1. So what I'm saying is that the last index number here being 4, it will now subtract 1 from this index number to give us the third index number. So if here is index number 1, here will be index number 2, and here will be index number 3. That's why our output stops here in 4. So it's a little bit trickish, but I know you will scale through this. All right. So there are common list operators. There are so many, I will not be able to disclose all of them. So I'll give you the major ones. So the first set of them are the ones you use to add items, right? So just like we have help me Lord. Yeah. So just like we have the list of integers from from one to um from one to from 1 to 5. If we want to include or if we want to add any other item, let's say we want to add 6 to it. The keyword or the function that we're going to use is dot append. Dot append, open a bracket, then include the value, put in the value you want to append or you want to add to the list you've created already. So here is it. Numbers dot append. So numbers is the original variable name for our list. And then dot append is the function that allows you to add a single element. Mind you, append only adds a single element to the end of the list. So whatsoever I'm adding now, it comes at the end of the list. So let's come and say we have numbers, right? We have sorry, numbers. If we print numbers, you'll be having from 1 to 5, right? So now we want to append 6 to it. So if I should say append 6 and I run this guy, it has added it to the list. So if I should print these numbers again, right? If I should print these numbers again, let's rerun it. You realize that we are having 6 here, while here we stopped at 5. So the same thing is applicable for extend, but extend, what extend does is that it adds all elements of another value. So this is extend will bring in the values you're including. So it allows you to add more than one element, right? It allows you to add more than one element, while append only adds one element to the already existing list. So if we should run this, and after running that, we now say, let's see what our numbers will look like, right? Let's see what numbers will look like. So here we'll have this. Realize that 7 and 8 has been added to the list of our numbers. So that is exactly what extend does. So extend allows you to add more than one element to the list. All right. There is another one that helps us to add items. But this one is very unique in the sense that it inserts elements or add elements to a specific position. So if I want to insert an element into a specific position or at a specific position, I make use of the dot insert function. So here, I want to insert 99 at index number 2. So I want to insert 99 at index number 2. Mind you, here we are having index number 2 to be what? 3. Because if I should run this guy, let's say, sorry about this. if I should run this guy, numbers, then 2, okay? So this will be 3 displaying for us now, right? So, but now I want to insert 99 in index position 2. So here, after your list variable name, you now have the dot insert function that comes up. And then after the dot insert, inside the bracket where you're to put the items, the first value that comes in is the index position. So index position 2 is where we are putting this item 99. So the position of where you're putting the item comes in first, followed by a comma, and then the item itself, and you close your bracket. So when you run this guy, you should be having something like this: 1 through 99, 3, and all that, right? So this will show that our number with index number 2 is what's going on? All right. So is 99. So that's handles that for insert, extend, and append. So because we say lists are mutable, it means we can add, and at the same time we can remove items from that particular list. So now we are going to look at removing items from our list, right? So when we talk about removing items, the first thing, these are the key functions we need to take note of. The first is remove. We have pop, and then we have clear. So for remove removes the first occurrence of a value. So the first value that occurs in this our list is what is going to be removed. While pop removes an item by the index. So when you don't indicate index, it removes the last value. So you always have to indicate index, otherwise you'll be removing the last value of your the last value of your list, or the last item in your list. While clear removes all the elements. So it's as simple as that. We say numbers dot remove 99. So now we are picking a value to remove. If we run this and then rerun the numbers, you realize that 99 is no more there. So for pop, we say numbers.pop last item. So if we run this and run this, remember, you now see that the pop has removed 8, which is our last index, our last item in that value. Meanwhile, for clear, if I should run this, it will remove all the items and my list becomes empty again. All right, so let's go to other operations. So we have len, L-E-N. So it's to get the total number of items in our list. Index is to find the first occurrence of a value. And then count is to count the occurrences of our value. Sort is to sort items in place. Reverse is to reverse the list. So the first one, so we now have another list that is known as norm. So we have 1, 2, random numbers like this. So if we run this guy, and let's first of all see the values. We have norm. All right. So having norm. So these are the values. So we can we want to get, let's do away with this print function so you see exactly what I'm doing. All right. So we said the first is len, open bracket, you enter the variable name, the list variable name. So this is it. 9. So it means we have 9 items. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, and 9 items. So we have 9 items in this particular list. So we can also, we talk of sort. We talked about sort. Sort has to do with placing the value in an ascending order. So when you use sort, it arranges your value in ascending order. So this is it now. I said norm.sort. Norm.sort. So if you run this guy and then you rerun the code, you realize that your norm is now what? Arranged in an increasing order, which is ascending order. Also, the reverse is used to rearrange it from ascending order to descending order. So let's run this guy and see. So we run the reverse and we rerun it. You'll realize that we are having what? This guy in descending order. So that is the major ingredients we needed to understand how list and list operations work. If you have any question, you let me know, maybe through the comments or the chats. So we're going to the tuples and their uses. Tuples and uses. So we said before that tuples are immutable, ordered collections of items. They are immutable ordered collections of items enclosed in parentheses. So this is another unique point for tuples. What makes it differ from the normal list we just talked about? So tuples are enclosed in parentheses, and once they are created, items in a tuple cannot be modified. Items in a tuple cannot be modified. All right. So creating tuples, we have empty tuples, just like the list we said before. We have empty tuples. So we can say tuple number 1, this guy, right? So you just saying tuple 1 equals to open and close parentheses gives you a tuple, right? So if you want to if you want to create a tuple, this is it now. Tuple 1 being equals to this guy, and you run this code, you have it that we've run this code, okay. So let's try to print. I hope this works. Oops. So it's not exactly what I wanted to do. All right. So let's rework on this. Okay. So I run this and then I call tuple 1, run this, realize is an empty tuple that is showing, right? It's an empty tuple that is showing. So we can also create tuples by doing this. We have tuples with one item. Note the comma. So once there's a tuple with one item, this is it now. You can have it this way. Okay, I think we can. This is it now. We have apple inside of this tuple, and then here is a tuple with multiple items. So if I should run the first one, I'm having what? Just an empty tuple, right? Then the second will give us, sorry, I've now run this guy. Okay, so let's rerun this to give us what? Apple. And the third one will output everything for us. So let's see accessing tuple elements. Similar to list, we use the same indexing and slicing, so I will not be explaining that so much. This is it. If you print this guy, 1 will give you 0, will give you 1. Then 1 to 3 will output 2 and 3. So what are the advantages of tuples? They are immutable, prevents accidental modification, which is useful for fixed collections like configurations, list, days of the weeks, months of the year, and all that. So those items that uh, you don't want to modify easily, you can use a tuple to contain them. Then for performance, tuples are faster than list for read-only operations. So when you want to read, you realize that tuples are faster than list. Then for hashable can be used as keys, right? It can be used as keys in dictionaries or stored insert if elements are hashable. So when we come to dictionaries, well, we have keys and values. Remember, mind you, tuples can be used as keys, right? So tuple operations, the major tuple operations we have are concatenation and repetition rather, not reputation, repetition. So the first is we have tuple 4. We want to include something to tuple 4. We want to add something to tuple 4. So here, let me bring out this guy first. So let's understand something very, very clear. Yeah. So I have all right, this is it now. Okay, so I can have tuple 4 coming in here. All right, tuple 4. Yeah. Okay. So tuple 4 will include, so I have tuple 3 being 1, 2, 3, and apple. So tuple 4 will include banana and cherry, just like we've indicated here. So for you to add something to a tuple, this is what you do. Tuple plus what you want to add, right? Tuple plus what you want to add. Then, having done that, we want to repeat. This is what we know what is known as concatenation. So even in list, we do concatenation, where you bring a tuple and marry it to another tuple to form a larger tuple. This is it now. So I'm bringing tuple 4, adding it to this other tuple, right? So having added it to this tuple, it will now give us what? Tuple 4. That will include 1, 2, 3, apple, banana, and cherry. That is it. So if you want to repeat the same thing, you make use of asterisk 2. Asterisk 2 will replicate every single item in that value. Sorry, in that tuple. So here is it. I have 1 down to cherry, and I still have 1 down to cherry again. All right. So that is it. So unpacking, we can have we perform unpacking in tuple as well. So unpacking is when you're given each of the values a variable name. So let's say, for instance, I have 1 to 4 being the values inside the tuples. And then I assign variable names A, B to C, D. So when you run this guy, and then you're trying to see which of these will bring out an item. So your B variable will represent 2, while your A variable should represent 1. So this is very useful when you're performing mapping, right? So when you're mapping, you can use unpacking inherent tuples to perform this particular task. So I have a practice code here that has to do with building of a to-do list, right? So the objective is to create a Python program that allows user to manage a to-do list and tuples. The program will include features like adding tags, viewing tags, and making tags as completed, right? And deleting the tags. So this is it. Just go through it. The code is very, very simple. The only thing is you just put in what is expected of you. So that ends the class for today. And that is it. If you have any question, reach out to me. I'll answer your questions.